So in the last one we found the outline of the nuclei reasonably well, and now we're going to identify the cells starting from the nuclei, so we're going to call that secondary objects. So we'll add them in here, and if you add them and you're in the wrong place, you can click on them, make sure they're blue. Frustratingly, if you click them and they go grey, then you can't act on them. You can make them go blue, and you can move them up and down and move them into the place where you want them. We have the warning here, obviously, because it doesn't have the right settings in place. So we want to take our Cyto original. Didn't do any smoothing on this one. We could do some smoothing and do some processing if need be. It might clean up the edges a little bit. In fact, let's just do that now. I'll throw it in place quickly with a smooth. So we'll add a smooth, make that blue, put that at the top here, and then we'll Cyto original, and we'll call it Cyto smooth. And I think it's nice to do a medium or a Gaussian filter. I'll have to wait for it to stop flashing. Now let's do maybe medium, and we'll do it manually and do something like 3, something small, and we will use that Cyto smooth on the way in. So let's use our Cyto smooth here. That's been smoothed a little bit with a medium filter. We can always go back and adjust that if we need to. And I've left the eye open here so we can see what it looks like. And we're going to call, we're going to select the input objects to be the nuclear objects here. So these are the starting points for us to try and figure out how to separate between the cells. And this one I find a little bit harder. There's a few more things convoluted together in the process, and I often seem to find what works well and then forget how I did it last time, so I can refer back to other files and things. But once you've got it set up for your particular cells, then you'll find it'll do pretty well across the board, and you can just tweak it a little bit based on your direction. So let's do a test mode. A lot of my CellProfiler work is empirical, so let's just do the run option. That will run all the way through, and a little marker will jump through stage by stage, and we'll see how it comes out here. We did the smooth, so let's just have a quick inspect on how that smoothed out our cytoplasm image. Maybe a little too much. So this is giving me a good opportunity just to step back and show you how we move around within our test mode. I'm going to bring this step back to smooth, and then I can step again if I need to. Note that if you have this one down here, and if I go to my smooth module and change my smoothing factor to 2, as soon as I change one of the parameters in this window, it will jump back up to that place, so when I hit step, it's operating at that point in the process. And that smooth is still a little too much. Maybe we can try a Gaussian filter and do, will it allow me to do 1.5? Let's try it. There you go, not too bad. It smoothed it out a little bit. May not need it so much. The data is quite defined at the edges, and splitting it up between the different cells is a subtlety with the settings, and it does it quite well once you find the right direction. So we're going to kill that window and turn off the smooth again. So identify the primary objects. We did that one. And for now I'm going to turn it off and not see that one again, and just play with the secondary objects. Frustratingly, most days when I'm playing and I've got more than one thing going on, if I've got multiple primary objects or secondary objects, they can start to look very similar, and I end up changing the settings on one, stepping, and then it will show me the settings from the second one, and I'll edit the settings for the second one, and I'll step through, and I'll end up getting confused between the two. So CellProfiler, if you're watching this, it'd be nice if you could somehow lock it to the one view here without it stepping forward, so I can keep for my tweaking of the settings. It will save me many hours, I feel. So we've separated out reasonably well here. This one I've thrown in what's called a little bit of a curveball. Not a term I used much until I moved here. And it's not going to grab these two bits so well because we don't have a starting point. It does really well when we have a middle point here. It's going to work away from the middle point. This part, it turns out, is really hard to break up, and I'm going to try and see if I can find out some subtleties to take that away. But for now, we're going to find out all the cells, and then just pick these 3 at the bottom. And you can take the data to make the analysis easier. Once you've done CellProfiler analysis a couple of times, when you go to the microscope, you'll pick the region of interest in the frame, the field of view to suit the analysis. You're going to try and crop in different places. You're going to try and surround the cells in different ways. Once you've done it a few times, you'll realise which things are a headache and which things on the borders are a bit of a pain. So let's go through a secondary object identification here and try and tweak this a little bit more. Just make sure I'm going to call this Cyto object. Just stick with my naming system here. And you've got a few different types. You can do propagation, watershed, and distance. Distance will just go away and in a certain way, and I've not really used it much. You can read the help file for some info, but I find the top three to be most useful. And all of the settings below, you can kind of get a situation where one of them with certain settings is very similar to the other one with another bunch of settings. So sometimes it doesn't matter too much as long as you can find something that works. We're going to do a global to start with. We'll do Otsu 3 classes, and this is kind of what I normally do every time I come to this software. Global Otsu 3 classes, and then I can play around with the foreground, background, the threshold correction factor, and here I have a regularization factor, which allows it to find the edges in it on its own versus just working away in terms of distance from the central points, and we'll do that in a moment. So let's just try that one, see how that works. Hit that again, and so that's done it pretty well. And this one I've known from playing around with. These are the ones that kind of work a lot for this kind of image where you have something throughout the cytoplasm, but they don't really have a very well defined boundary. And each time I come to a different cell type or a different staining throughout the cytoplasm, these settings can vary. So post your comments, let me know if there's any questions. I can try and attack certain datasets. If you want to send me datasets, that might be fun too. Okay, so it's done a reasonable job. Let's try and make it a little bigger. So you can see the edge here. These lines look kind of straight between the two cells, and it's kind of strange. We've got a little bit more curvature going on. So this regularization factor in one direction. Remind myself which way. Let's try 0.1. Let's step again. Let's go the other way. Step again there. There you go. We're going to go smaller, and now it follows the boundary a little well. It's not perfect. It hasn't got on this bit here, but it would be near on impossible in Fiji to get anything usable that actually followed the edge of the cell. Let's try and go a little lower. See how that works. There you go. That's done a pretty good job. Okay, so I'm gonna omit this cell on this top right here, the yellow one. I've played around before with this kind of thing. It's difficult to get it to separate at these boundaries here that are kind of undefined, and it's easier to just omit those ones from the data sets and just run through the numbers, and we're going to omit that based on size. And we'll come back to that one in the next one. We're going to do some measurements, filter the objects, and we can move forward to giving us some outputs. But that's the kind of starting point for trying to separate out the cytoplasms between the cells, the secondary objects.